Today we're looking at systems of nonlinear equations. This is lesson number 8 in Unit 7. We want to revisit systems of equations where the equations are not always linear. We can use the methods of graphing, substitution, or elimination that we learned earlier for this unit. First of all, our example here is by substitution. I'm also going to leave us room to graph since we know we have a circle here, but using equation 2 as a substitute for the y term into equation 1, we can look at the substitution method. So expanding this binomial, we'll end up with 4x squared plus 20x plus 25. And collecting like terms on the left-hand side will give us 5x squared plus 20x. And factoring out a 5x from each of the two terms leaves us with 5x times the quantity of x plus 4. So we have a potential solution when x is 0 or when x is negative 4. Now going back to equation 2, if x is 0, then y is negative 5. And using that same equation, if x is 0, then y is if x is negative 4, then y is negative 2 times negative 4 minus 5, so y is 3. That tells us that we're going to have two solutions, one at 0, negative 5, and one at negative 4, positive 3. So looking at the equations, we know we have a circle whose radius is 5, and we have a line that is a negative slope. So carefully draw this circle here. And a little off there. And then negative 2x minus 5 means we're going to start here and the slope's negative 2. So there's where our intersection is. And we have that line going through there. And we can clearly see here's one solution. When x is negative 4, y is 3. And here's our other solution. When x is 0, y is negative 5. So that's pretty straightforward. Just a review of things we know from Algebra 2. Okay, in the next equation, we're going to look at elimination method. So I think we could multiply the equation 2 by negative 2 all the way across and add it to equation 1. So leaving equation 1 as it is and multiplying negative 2 to each term, we'll find out that y is negative 9. And then going with back substitution into 3x squared plus 2 times y is positive 9. So 3x squared minus 18 is 9, which tells us 3x squared is 27. And dividing by 3, x squared is 9. So x is either 3 or negative 3. So we have solutions when x is 3, y is negative 9, and when x is negative 3, y is negative 9. And we would have, let's see what we got, 2 parabolas. So one parabola is y equals negative 6x squared plus 9 divided by 5. And the other parabola is y equals negative 3x squared plus 9 divided by 2. And I believe just for practical terms, instead of me trying to draw that, I'm going to look at that on my calculator here. So we have negative 6x squared plus 9 divided by 5. And then move that out of the way. The second equation is negative 3x squared plus 9 divided by 2. Move that out of the way. And then analyzing the graph with the intersection. And then doing that again, analyze the graph with the intersection. And we have an intersection at 3, negative 9, and negative 3, negative 9. So we can see those solutions. Okay, so moving on to example 3. We want to find all the solutions of the system by graphing. So in this case, since they're both equal to y, I'm also going to use algebra to solve. So when is 4 minus 1/2 x equal to negative 1/2 x minus 2 quantity squared plus 6? So we have on the right-hand side, we could get negative 1/2 x and subtract 4, and then multiply by, how about if we multiply by negative 2? So that's going to leave us with x and positive 1 and 4. So on the right-hand side, we have x squared minus 4x plus 4 minus 4. That's gone. And then x squared minus 5x is 0 when x is 0, or when x is 5. Now back here, when x is 0, y is 4. So we have a solution at 0, 4. And when x is 5, we have a solution at 4 minus 2.5, which is 1.5. And our solution will graphically appear when we have 4 minus 1/2 x, down 1, down 1. So we have the line going here. And we have a parabola that shifted 2 units up and 2 units right and 6 units up. So 0, 4, down 2, down 2. And then where was the other one at 5, 1.5? Oop, I got a little off in my drawing there. So we're going to say this point is 5 and 1.5, and this point is 0, positive 4. So the two solutions are contained on the graph, and we solved that algebraically as well. Now our last example, so this was really a quick lesson. We want to find all the solutions of the system correct to 3 decimal places. So this looks like we have a circle and a parabola. Again, I'm going to depend on my technology here. So clearing that out, make this a little bit bigger. So back to the graph, we have a parabola at 2x squared minus 6x. And then the circle, we need to solve for both square roots. So 1 is going to be the square root of 16 minus x squared. That's going to be the top half of the circle. And the other is going to be the negative square root of 16 minus x squared, which will give us the bottom half of the circle. So solving for the intersections, I'm going to stack these up on top of each other. So we're going to analyze the graph looking for the intersection. So I want this graph and the blue parabola, which will give us that point there. So we have one, we'll call that point A. So I'm going to call, we'll call that point A. And then menu, we were looking for the intersection. So the other one over here, we'll call this point B. And then analyze the graph for the last intersection. That would, no, there's two more, aren't there? And that one, whoop, second graph. So we're going to do this one. We'll call this one point C. And for finally the last point of intersection, so the parabola and the black portion of the graph, point D. Whoop. Okay, so if we grab this picture, place that picture into our document here, then we said the first one we were going to call point A. That was over here. So point A intersects at negative 0.557, 3.961. Point B intersected over here. This was B. That intersected at 3.332 and 2.213. I'm rounding up. This point was point C. And point C intersected at 0.946 and negative 3.886. And then we said this was point D, and point D intersected at 2.279 and negative 3.288. So that puts us at the end of lesson 7. We have one more lesson in this unit. I'll be back to guide you through that. See you next time.